Hi learners, within this video I am going to discuss few frequency response specifications. What is frequency response? Let us consider a system to which a input sinusoidal signal is given as the input. Input signal, let it is represented by RT is equal to A sine of omega naught t. Then the output is given as CT is equal to A into J omega naught sine of omega naught t plus angle of GJ omega naught. It means that if a sinusoidal input is given to the signal, then depending upon its transfer function, its magnitude gets modified by a factor GJ omega naught, and a phase angle of JJ omega naught will be added to it. If we talk about the frequency response, then frequency response means to sketch the variation in magnitude and phase angle of GJ omega as omega is varied from 0 to infinity. Then this variation of amplitude of the signal with omega is termed as the magnitude response, and the variation of phase with respect to the frequency is termed as the phase response. So like we have a number of specifications with respect to the time response. Similarly, in the case of the frequency response, we have a number of specifications which are to be specified for a particular system. These specifications are resonant peak, resonant frequency, bandwidth, cutoff rate, gain margin, and phase margin. What is the resonant peak? Let us consider that a overall transfer function of a system, it is given as Ts is equal to omega n square divided by s square plus 2 delta omega ns plus omega n square. Here omega is n is the natural frequency, and delta is the damping factor. Then we substitute s equal to j omega, and then we separate the real and the imaginary part. So by mathematical manipulation, we just get this expression for tj omega. Now we substitute omega divided by omega n. This s equal to u. So that will give us tj omega is equal to 1 minus u square plus j 2 delta u. Now from this expression, we can separate the magnitude and phase angle of tj omega. Magnitude of tj omega is equal to 1 divided by, this is of the form a plus jb. This is its magnitude will be equal to root of a square plus b square. So magnitude of tj omega will be equal to 1 divided by this square plus this square. So this will be the magnitude of tj omega. Similarly, angle of tj omega will be equal to minus tan inverse b divided by a. So this is of the form a plus jb. So angle corresponding to this expression will be equal to tan inverse 2 delta u divided by 1 minus u square. Since it is in the denominator, so there will be a minus sign associated with it. So this is the magnitude of tj omega. This is the angle of tj omega. Then the maximum value of the magnitude, if we just take up the variation of this magnitude with frequency, that will be called the frequency response, and the variation of phase with respect to the frequency will be termed as the phase response. And maximum value of this amplitude is termed as the resonant peak, MR. That is the first specification, that is the resonant peak. Now the next specification is the resonant frequency. It is the frequency at which the magnitude of the frequency response has peak value for the first time, and it is represented by omega r. Now, how do we get the maxima? Maxima is obtained when the first derivative of magnitude becomes equal to 0. So, to obtain an expression for the resonant frequency, we substitute dm by du. This is m. We take up its derivative with respect to u. U is what? U is equal to omega divided by omega n. So this we have taken earlier. This is omega divided by omega n is equal to u. So omega n is fixed. We just vary the omega, and corresponding to that the magnitude will be changing. So the variation of magnitude with respect to the frequency will be the magnitude part of the frequency response, and at whatever will be the maximum value of m, that will be the resonant peak, and the frequency at which the maximum value of m occurs, that is called the resonant frequency, and that is obtained by just taking the, because maxima is wherever the derivative of m becomes 0 with respect, derivative of m with respect to frequency becomes equal to 0. We take up the derivative of m with respect to the frequency, we equate it as equal to 0, then that particular frequency is termed as the resonant frequency, and the resonant frequency is found to be omega r is equal to omega n root of 1 minus 2 delta square. Here delta is representing the damping ratio. Then the next term is bandwidth. Bandwidth is also one of the very important characteristic, frequency response characteristics. This is the magnitude curve of the feedback control system. On the x-axis we are having the frequency omega, on the y-axis we are having the magnitude that we have defined earlier. So the frequency at which value of m is 1 by root of 2 is termed as the cutoff frequency, omega c. So at omega equal to omega r, means at resonant frequency, the magnitude becomes equal to the resonant peak. So when omega is equal to omega r, in that case, the this is the resonant peak occurring, and the frequency at which the value of m is 1 by root of 2 is termed the cutoff frequency. This is the cutoff frequency. At cutoff frequency, the value of the amplitude is equal to 1 by root of 2, that is equal to 0.707. The range of frequency over which m is equal to or greater than 1 by root of 2 is defined as the bandwidth. So this is 1 by root of 2 here. This range of frequency for which m is greater than or equal to 0.707 or 1 by root of 2, this is termed as the bandwidth. And for calculation of the bandwidth, we first of all take up at omega equal to 0. Omega is 0. What will be the value of u? U is equal to omega divided by omega, and u will be equal to 0. And the value of m, it will become equal to 1 minus, you can use this expression, m, this will be equal to 1 divided by root of 1 minus 0 square plus 2 into 0. So this will be equal to 1 divided by 1, so it will be equal to 1. So when omega equal to 0, m will be having a value equal to 1. Therefore, the magnitude of Tj omega is 1 at omega equal to 0. At 3 dB frequency, the magnitude of Tj omega will be 70.7% of the magnitude of Tj omega at omega equal to 0. So it will become equal to 1 by root 2. So m is equal to 1 by root 2 when omega is equal to omega b. What is omega b? You can very well see from here. This is the bandwidth. So this is 0.707. This is omega c equal to omega b. So this is, this we have calculated. This is 1 by root of 2. So when m omega is equal to omega b, then m is equal to 1 by root of 2. We just solve this equation, we get the value of ub, and the value of ub is coming out to be x is equal to this. So ub is coming out to be equal to this, and ub is what? This is omega b divided by omega n. So when we substitute, we get the value of the omega b. So we have got the expression for the bandwidth of the system, and it's a very important characteristic because it simply tells that how much noise can enter into the system, how much range of frequency are allowed within the system. So in case the bandwidth is more, it means that more noise can enter into the system. Bandwidth is less, it means that less noise can enter into the system. Then next specification is the cutoff rate. It is the slope of the log magnitude curve in the cutoff frequency. It indicates the ability of the system to distinguish the signal from the noise. So it is thus, this is the curve. This is the slope here, over here. This is termed as the cutoff rate. Then one more specification that we have talked about, that is the gain margin and phase margin. These are very two important characteristics, frequency response characteristics of a control system. Phase margin and gain margin represents the relative stability of the system. They specify the amount of additional gain or additional phase that can be added to the system to bring the system to the verge of instability. More gain margin and more phase margin means the system is more stable, and less value of the gain margin and phase margin means that the system is less stable. So these are the frequency domain, the specifications with respect to the frequency response of the system. And these specifications are somehow related to the time response specifications, and both of them are having interrelation with each other. So this interrelation will be discussed by me with the viewers in my next video. Thank you so much for the patience hearing.